This is the second in the video tutorial series on editing fuzzy inference systems in MATLAB. We're going to go ahead and bring up the fuzzy inference system editor in the fuzzy logic toolbox. And once we've done that, we're going to go ahead and we're going to go to File, Import, and we're going to import the fuzzy inference system that we saved on our desktop in Part 1, and that was this FIS tutorial. The FIS tutorial is a straight-up copy of the fuzzy inference system that is the default for the geomorphic change detection software. I'm going to close this untitled one that we're not using behind here and make the editor a little bit bigger so you can see what's going on. So this is the two-rule system. There was a 2 and a 3-rule system described in both the Wheaton 2008 thesis and the Wheaton et al. 2010 Earth Surface Processes and Landform paper. This is the two input system that relies on slope and point density as inputs and elevation uncertainty as an output. So let's take a second to get familiar with where things are organized in this little fuzzy inference system editor. Up top shows you a graphical of how your inference system's put together. On the left are the inputs. You can have as many inputs as you want. You can add more inputs very easily. In the middle is basically just a representation of the inference system itself. The methods that it uses are all described here and very well documented. I would suggest you stick with these defaults unless you have read through all the documentation and have a really strong basis for changing them. You'll find that some are pretty critical, but that some you don't actually see that much sensitivity in the outputs to these methods. And then there is the output that's represented on the right here. And so we've got elevation uncertainty. You can call these inputs and outputs whatever you want. If you highlight one of them, this is where you change the name. The only thing is the names cannot have spaces in them. And so that's why you see the ELV, elevation uncertainty, and the point density here with no spaces. If I want to edit any of these membership functions, I simply double-click on it to bring up a membership function editor. And I'll go through how we can edit that in just a moment. If I want to take a look at the rules here, I go to the Edit Rules, and then I can see here I've got 9 rules. The reason I have 9 rules is because I have 2 inputs, slope and point density, and each of those inputs have 3 membership functions, low, medium, and high. So 3 times 3 is 9. So what we will do next is show you a pretty handy little way of kind of getting a feel for how this rule system works. Actually, why don't I go back to those rules real quick. So the basic logic here is that our elevation uncertainty is some trade-off between the topographic complexity represented with slope and our sampling pattern represented with point density. And basically, if point density is high, and then we're on a flat surface, we've got lots of points on a flat surface, or a non-complex surface, low slope, then the elevation uncertainty should be very low. And if we contrast that with a condition where our slope is very high, and our point density, we hardly have any points, then our elevation uncertainty is extreme, and the rest of the rules represent the stuff in between those sort of two end members. And so that's the basic logic behind this rule system, and that's all spelt out in those previous papers that are cited on the website. And if I want to see actually how that works without having to run through in the geomorphic change detection software, is a bunch of examples of it. Going to view the rules is a really handy little tool. And so this little tool basically allows us to specify a slope. And so if we specified a fairly, moderate slope, let's say something like, well, this is 8.29, I can use the slider bar, or I can specify it exactly by, if I wanted to get it right at 10, I could just type in 10 there. I'm going to actually, 10% will work. And then point density of 2.5 points per square meter for a total station survey would be quite high. Let's make something a little more realistic, something more like, let's see, 0.5, okay? And so what we have in this example here are, if we go through slope of 10%, that comes up on the input membership functions as a medium slope. These would be lows, this is medium, and then these would be high. Whereas the point density comes up also as a medium point density. And so if I look at that, I have 3 potential rules shown in yellow for point density and 3 potential rules shown in yellow for slope. But it turns out that only one of these is actually going to be implemented, because this is the only rule, Rule 5 here, where the slope is medium and the point density is medium. Therefore, the elevation uncertainty here is, I think this is referred to as average, if I remember. And so when I take the total consequence of all these rules, it is just that average uncertainty. And what this is a fuzzy representation of our uncertainty. And so it's saying that the elevation error or surface representation uncertainty could be anywhere from this value, which is probably somewhere around 10 centimeters, on up to this value, which is probably somewhere up around, I'm guessing, 20 centimeters. And then the when we defuzzify it, this red line, 14.6 centimeters, that is the crisp value that we're going to use as our estimate. So that's a simple example. Now if we change that to, let's say, a lower slope, let's say 2% slope, and let's say a really a high point density, let's say 2 points per square meter, okay? So 2 and 2, I've still got 3 possibilities here. Oh, actually, I'm sorry, I want to show you a different example. What I'd like to do is get you somewhere in the middle here on the slope, so that, there we go. So now if I change this to 6%, now I've got 6 possible slope rules and 3 possible point density rules. But what happens is 2 of them are actually realized here. And so I've got 2 potential membership functions. One's going to be a low and this other one's going to be a medium or something. And so when those 2 get combined, I get this odd shaped looking membership function, which is the total consequence of both of those. And then when I defuzzify that, because of more of the mass being pushed by this low membership function over on this side, I get a very low elevation uncertainty of 2.4, 2.5% roughly. I'm sorry, 2.5 centimeters for that example. So that's a really handy way of you can play with your fuzzy inference systems, which we're going to go through in the Part 3 tutorial. But you can play with the membership functions, you can play with the rules, but what you can do is then go to this rule viewer and then just see, okay, well, how does that influence my elevation uncertainty? And what I can see here is, I can change my point density a whole bunch, and I'm not going to change at all my elevation uncertainty, right? Because it's just staying up here at that 24%. When I have a slope like this. And so you can see how sensitive or insensitive it is, and if you want to make it different, then you simply change your membership functions, either the input or the output, or you change your rule system. So that's it for this part.